Here's the mean value theorem for a second problem to show that find a value c such that the slope of the tangent line at that function is equal to the slope of the secant line of that function between two points there, -1 to 2. Here is just an idea of where we're going. I'm going to graph that thing, x cubed minus x minus 4. That's one that I don't know exactly what it looks like. I know it's a cubic, and I know it goes through 0, -4. I can put it in on Desmos, or maybe in on a graphing calculator, and it's going to look something similar to this, I think. Something like that. And I'm going to use those 2 points, -1 and 2, and when I put a -1 into that function, I get -1 minus 1 minus 4. That's -1, -6. And when I put a 2 into that function, I get 2 cubed plus 2 minus 4. That's 8. 10 minus 4, 2, 6. So here's what's happening with the mean value theorem. Between those, if the conditions are met, between those 2 points, I can put in a secant line here in red. And that has a certain slope. It looks like it's sloping upward. Somewhere in that function, again, if conditions are met, there's going to be a number that the slope of the tangent line through that point is equal to the slope of the secant line. It looks roughly somewhere in here, in that area. We can find it. It looks like there's only one. Here's how we do it. First, we need to verify conditions. We know that x cubed minus x minus 4 is a cubic. So it is continuous everywhere. And f of x is also differentiable over that open interval. There's no place where we can't take a derivative. There's no cusps, no endpoints, no vertical asymptotes on this one. So it's also differentiable over that open interval, -1 to 2. Our conditions are met. We can proceed with what the mean value ensures. By the MVT, there is a C within -1 to 2 such that f prime of C equals f of 2 minus f of -1 over 2 minus -1. The slope of the tangent line, that's f prime of C, equals the slope of the secant line. So now it's kind of algebra mode and cranking things out. I'm going to deal with the left side first, find f prime of C. First we need to find f of x, which is the original function, x cubed plus x minus 4. The first derivative, f prime, is 3x squared plus 1. So f prime with a c in it is just 3c squared plus 1. That's on the left side, 3c squared plus 1. Now on the right side, that's just putting those numbers through the function. We've got them already. F of 2 is 6. F of -1 is -6. 2 minus -1 is 3. 3c squared plus 1 equals, that's 12 over 3 or 4. 3c squared equals 3. c squared equals 1. So if we're solving that, c could be plus or minus 1. And so it looks like there's two places there where the slope of the tangent line is slope of the secant line. One of those places is x equals 1, kind of confirmed. And the other place is x equals -1. But, oh, hold on a second. That does look like it's, but that's right on the interval. So because -1 is not part of this interval, we can rule out that -1 and just say that c should just be +1. That letter or that variable has to be in the open interval. I think it is true that the slope of it right at -1, but just make sure that within that problem we are just looking from -1 to 2. So that value is c equals